What's up, guys? This is Karek from Algebra. I'm a bro that's gonna help you, and we're back. We are going to do some analytical geometry for the grade 10s, just to brush them up, because I know it's term 3, that's a big topic for them. So, uh, what I'm gonna go through is gonna go through a question paper, and when it comes to analytical geometry, this part here very important because you need to read through it because they give you a lot of information there. And also, what you also need to know is this is like a little cheat sheet for analytical geometry. You can take it with you to grade 12. Very important. We have the distance formula which is going to be that midpoint formula, middle, it's going to be that gradient, para. That's the three forms you need to know. Then you also have to know some theory. Parallel lines, gradients are the same, so when you have two lines uh, that are parallel to each other, the gradient will be the same. Perpendicular lines, if you multiply the two gradients of the perpendicular line, for example, this line's gradient times this line's gradient should equal to -1. You need to know that because that's going to be very important for you in analytical geometry. Then you also need to know your inclination angles, right? So tan of your inclination angle equal to the gradient of the line. I'll show you that when we get there. Straight line graphs, very important also when it comes to analytical geometry. You need to know this, your straight line graph. You need to know how it works because it's going to be key when working with analytical geometry. Okay. When lines intercept, you just equate the equations. Okay, I know that's a lot, but as we go through the papers, you'll see how I use it and how you can use it to get full marks. Cool. Let's start with the first question. Question 3. In the diagram below, P is the coordinate is going to be 2 and 9. So remember that's x. That there. So x will be 2, y will be 9. Here in this case, r will be, the x there will be n, and the y will be -1, -13, sorry. And m of vertices or the parallelogram. Okay. Vertices mean points. Those are the points. So P is one vertex, A is another vertex, R is another vertex, and M. Right, so those four dots connecting makes a parallelogram. And that's very important to know because you need to know the properties of parallelograms. Okay, so the properties of parallelogram is that the opposite sides are parallel to each other. So you can see parallel and parallel to each other there. Also, you need to know that the distance or the length of this side will be the same as that length there, and the length of this side will be the same as that length there. Okay, remember that. Let's continue. So PARM, PARM, which is now your parallelogram that you have. Next, PMT, PMT. So that line is a straight line. That M is the midpoint. So this here will be the midpoint. Okay, cool. We know that now. Then let's say that T, they give you the coordinates. So that's X and that's Y, is a point such that PT, so the PT must be perpendicular. That means perpendicular to RT. So here's RT. Okay, so you need to know already. Remember what I told you with the notes? If two lines are perpendicular to each other, the gradients, if you multiply them, should equal to -1. Okay, cool. Now we have some information to work with. Let's start. So the first question is, you need to calculate the length of PT. Leave your answer in surd form. So surd form just means this. So if your answer is that, you leave it in that form. Okay. So let's go. So for PT, so here's P and there's T. I'm going to use those two coordinates. The formula that you're going to have to use is the distance formula. So let's go to our little cheat sheet. Here's our distance formula. I'm just going to copy that quickly. This is for question 3. 3, 3.1.1. Okay, distance of PT. There's your distance formula. Now you have to substitute. So you see as a x1, a x2, a y1, and y2. And what that means is, so for example, because remember we're working with these two coordinates, this will be my x1 and that will be my y1. This has to be my x2 and that must be my y2. Alright? They must always go together. This can't be y1, that can be y2. That doesn't work. It has to be x1 and y1, x2 and y2. Alright, you can swap them around if you wanted to. So this could be x2 and y2, x1 and y1. Alright, again, they must go together, very important. Okay, let's substitute it in. So for in this case, x1 is going to be 10. So x1 is going to be 10 minus x2 will be 2 there, to the power of 2 plus y1 will be negative 3 minus 9 to the power of 2. Okay, cool. Let's substitute this in our calculators. Ten minus what was it? 2. 10 minus 2 squared plus negative 3 minus 9. Right, there's your answer. See, instead of writing now 7.2111, you can just use the third form, which is 2 square root 13. 2 square root. And there's your 2 marks. Very simple and very easy. Okay, cool. Next question. The gradient of PT. Okay. Now go again. Hello formula sheet. You'll see your gradient is equal to y1 minus y2 over x1 minus x2. So I'm just going to take this formula again. See, a lot of analytical geometry is just about substitutions. So 3.1.2, need to find a gradient of PT. So M PT. So again, if you look at this, okay, if we look at this here, it's gonna be again x2, y2, x1, y1. Important to keep them together, people. Okay. So remember, the y's are coming first, not the x. So on top, so y1 is negative 3 minus 9 over that day is a 10. So 10 minus 2. Substitute that in your calculator again. So minus 3 minus 9 over 10 minus 2. Your answer is negative 3 over 2. Negative 3 over 2. Okay, there's another 2 marks. Simple so far, guys. 4 marks. We are moving. The gradient of AR. And you can see it's only 1 mark. And you're probably wondering why is it only 1 mark, but the other one was 2 marks. I'll show you now why. It has to do with our reasons, the theory work. So we calculated this gradient to be negative 3 over 2, right? But you'll notice that this line where AR, yes, AR, which you also cannot use a normal calculation to work out the gradient because you don't have the coordinate of A, you don't have the coordinate of R fully. So you can't use the y minus y over x minus x like you used in the previous question, because you don't have all the information. But what you can realize is that PT is parallel to AR. And remember what I said here, parallel lines, gradients are equal. So now you know that if the gradient of PT is 3 over negative 3 over 2, then the gradient of AR should also be negative 3 over 2. That's where the theory comes in. And that's why it's only 1 mark. Because you don't have to do any calculations, you need to know your theory. So the gradient of AR will equal to negative 3 over 2. Okay, perfect. So we are continuing to our next question. Question 3.1.4, the coordinates of M. Okay, so we need to find what the coordinates of M is. You'll notice that those two lines have the same two little dashes. That just means that this length will be the same as that length there, meaning M is our midpoint. Okay, so if M is our midpoint, and they do say that M is the midpoint here, you just need to use your midpoint equation or formula. So here I'm going to take this one here, copy. This is going to be 3.1.4. The midpoint of it will be so again we're going to use our same coordinates for PT. Erase everything else, it doesn't look so cramped. Okay, so x1 plus x2. X1 will be 10 plus x2 will be 2 over 2, because remember it's halfway, divided by 2, halfway point. Right? Same for the y values now. So y1 was negative 3 plus 9. Okay, and our answer 12. So 10 plus 2 gives you 12 over 2 will give you 6, and negative 3 plus 9 will give you 6. 6 over 3, 6 over 2 will give you 3, and that is your coordinates. This will give you 4 marks. Was it 4 marks? No, it was 3 marks. Okay, easy 3 marks, people. Just remember you need to know all your formulas and you should be good. Now we go into question 3.2. Determine the equation of PM in the form y is equal to mx plus c. So remember what I told you guys at the beginning? Straight lines are very important when it comes to analytical geometry. You need to understand how it works, because they're going to throw it in every time. Okay, so we need to find the equation of PM. Where is PM? So you'll see that's M. We know the coordinates of M is, we just write it in here, 6 and 3, and there's P. So they want us to work out the equation of this line. Okay, so when you're working out the equation of a line, there's 2 things you need to know or work out. Question 3.2. It's going to be, you write down your standard formula. You need to know that this stands for gradient. That is your y-intercept. Okay, so in our case, we can work out this formula, the gradient of P and M, but you also need to know that you already worked it out, because the gradient of PT was negative 3 over 2. right? So the gradient for P to M should be the exact same because they're on the same line. Negative 3 over 2. But just for us to see that it's true, let's work it out. So we're going to work out now from P to M, the gradient of that. So the gradient formula again, y minus y over, sorry, start down again, y1 minus y2 over x1 minus x2, right? We have to use P and x. So I'm going to make this now x1 and x. And this is y1. Okay, so 3 minus 9. So that's a 3 of this point. Minus that 9 there. 3 minus 9 over 6 minus 2. So 3 minus gives you negative 6 over 4, which is equal to negative 3 over 2. And as you can see, the gradient is exactly the same. Okay? Because they are collinear. They are on the same line. Collinear meaning on the same line. Perfect. So now we know that our gradient is negative 3 over 2 x plus c. So our problem is we need to still find c. So again, from the beginning, when you're trying to work out the equation of a line, you need to work out the m, and we need to work out the c. We have worked out the m now. You need to work out the c. And the way you do that, it's very easy. All you have to do is substitute any point that is on that line. So any point that is on this line. And there are 2 points that gave us at the beginning of this question. They gave us P and we already know what N is. So you can use any one of them to find what the value of C is. So I'm going to let's use that one. Now let's use P first. So the Y value for P is 9. The X value for P is 2. Right, let's work this out now. Okay, this will cancel out with each other. Bring the 9 up. So it'll be 9 plus 3 equal to 12. Alright, there you worked out C to be 12. But let's use the other coordinate just to so I can prove that you can use any of these points. So remember C is equal to 12. So now instead of using the coordinates of P, let's use the coordinates of M. Okay. So I'm gonna put in 3 here, is equal to negative 3 over 2. The X value for this will be 6 plus C. 2 goes into 6 3 times. So negative 3 times by 3 will give you negative 12. Oh no, sorry, negative 9. Bring over the 3. So 3 plus 9 equal to 12. And as you can see, you get the same answer. And with there we have worked out what the value of C is. Cool. So now I can put in the place of C 12. And the other question is done. 3 marks, people. Very easy, guys. Again, when you are doing analytical geometry from grade 10 to grade 12, you need to know your rules. You need to know the theory behind it. For example, the parallel lines, the perpendicular lines. Very important to know that. And also your normal formulas. Then you should be good. Thank you very much for joining me. I'll see you in the next video. Have a good day.